Good evening, good evening. Yes, dear students. Arjun, Jagdish, Satish. Okay. Very good evening all. Very good evening. Come on, join this session very fast. Sayan Mondal, hi dear, how are you? Yes, come on, join this session very fast. I welcome all of you here on this very beautiful platform, that is Gradeup, the India's largest e-learning platform, dear students. And dear students, we have started this production engineering for Vizag 2020, this management trainee recruitment. This is the practice session of the production engineering. This is the second part. Yesterday we started with the first part with the casting technology. Chahat, very good evening dear. John, very good evening. Prakash, hi, hello. Shivani, Arjun, once again, please come on. Very fast, join this session, dear students. So today's session will be looking for the metal forming or including the sheet metal operations. We'll try to learn that. We have some practice on that. Come on, dear students. Come on, join the session very fast and share this session, dear students. Share this session with your friends, right? And do follow me on the Gradeup app. Do follow me on the Gradeup app. So shall we start the today's session? This is the very short introduction about me. I am Onkar, having more than 10 years of experience for teaching GATE and ESE. I have mentored more than 10,000 number of students for the GATE and ESE examination. My area of expertise are production and industrial engineering and the fluid mechanics as well. So chalo bhai, chalu karte hain aaj ka session regarding to the metal forming and the sheet metal operation. Are you with me? Are you with me? Are you with me guys? So that we can start. Yes, come on. भाई मूवमेंट होनी चाहिए चैट बॉक्स में. चैट बॉक्स इज स्टॉप्ड. Am I audible and visible? Let me know. Am I audible and visible to all of you? Am I audible and visible to all of you, Arjun? Okay. Please comment in the chat box so that it will be the interactive session, dear students. Fine. Take this first question. See, flash and gutter. The first question is related to what? The flash and gutter. Suppose this is the upper die half and this is the lower die half. Okay, and I have placed the material there. Okay, of course this is the closed die forging is there, dear students. And we know that in the closed die forging operation, the raw material that we are keeping is generally 10 to 15 times more than percent more than the original volume of the product. Yes, of course, to accommodate with this extra added volume, because we want to confirm that to the each and every corner in the die cavity our material should reach and it take the shape that they having the impression on the die. So we are looking for that. So definitely this excess material, after filling the regular size, where this excess material will go? For that reason, dear students, because see, when in the closed die forging the dies are closed, where this excess material will go. So for that reason, dear students, हम क्या करते हैं, we are giving the gutters into the dies. So these are such a kind of gutters, so that the excess material, after filling the actual mold cavity, it will flow into the gutters, and it is going to produce the flash with the final product. So this is the flash which is made because of the gutter, and this can be trimmed out, this can be trimmed out, this can be trimmed out, it can be cut, get clean by the trimming operation, okay. So definitely no any external or open forging technique the flash is going to generate, dear students. So flash and gutter, actually here the word should be the flash and gutter, these are two different things. The effect of the gutter is the flash. So A is correct answer. Very nice, excellent, dear students, excellent. Okay, fine. I want such a kind of reaction, such a kind of interaction for every question. Let us go to the next. Yes, beautiful public is there, intelligent audience is there. Yes, hot working of the metal is carried out. Hot working of the metal. Dear student, if you look at the metal forming process, so see, for every question it is simply not like that. So question and answer, we are going to discuss something, some background about that question, so that things can get revised at this moment. Yes, Chahat, Shivani, yes, come on. Money, very nice, Money. Arjun, very good, come on. Dhirendra Kumar, very nice, dear. Yes, Chinni Anurag, yes, A, that is very common thing, dear students. The recrystallization temperature, if you working on the material above the recrystallization temperature, dear, definitely it is known as the hot working process. And when we are straining the material below its recrystallization temperature, it is known as the cold working process. And generally this recrystallization temperature is what? Yes, Ashish, very good. Prakash, very good. So this recrystallization temperature, dear student, is nothing but what? The temperature at which the formation of new grains or new crystals has been completed by the application of force and pressure, force or heat or pressure or heat. This is known as recrystallization temperature. Yes, Gohel, see how it could be though, Gohel. Okay. So dear, please remember this recrystallization temperature is generally 1/3 to half से लेके half तक of the melting point temperature of the material. Based on that, you can have the different materials like which can be having the working below room temperature. Also, if you take the lead and tin as examples, so their recrystallization temperature is -4 degrees centigrade below room temperature. And means if you even work them at a room temperature, it can be treated as, or it is called as the hot working. And even you take the example of tungsten, dear students, which is having very high melting point temperature, that is around say 3300 to 3400. Its recrystallization temperature around 1200 degrees centigrade. And even if you are working on the tungsten at 1100, suppose 1100 degrees centigrade पे हम tungsten के ऊपर काम कर रहे, still it is known as, it is called as the cold working. So that is the thing, that is the beauty of it. So please, I hope it is clear to you. Next question. The forging of the steel specimen is normally done at, yes, forging. So please remember that. What is the recrystallization temperature actually for forging for the steel? Tell me what is the correct answer. Yes, come on. Khadse Sahib, welcome. Dhirendra, yes, come on, join the session and like the session. Follow me on the Gradeup app. Yes, come on. So yes, it is nearly about 1000 degrees centigrade. Okay, so nearness to the 1000 degrees centigrade, of course dear student, it is, you can take it as 1100 degrees centigrade. B Bombay is the correct answer dear students. Please remember that it is 110011. See, 15,000 degrees centigrade is actually 1539 degrees the melting point, where you are going to work on that steel for the forging. At that temperature steel is going to melt. Please. So B is very precise, very correct, nearness to the reality, that is yes, it is 1100 degrees centigrade you can take. Please. I hope B is the correct answer. B is the correct answer. 1100 degrees centigrade. 1100 degrees centigrade. Next question. In order to get the uniform thickness of the plate by rolling process, in order to get the uniform thickness of the plate by the rolling process, one provides. Please understand the question and tell me the answer. So dear student, what is the cambering? The question now comes, what is camber or what is cambering? So dear students, I will just give you the hint. The camber is like this, because when we consider the roller as a simply supported beam with the uniformly distributed loading, okay, so there will be the deflection you can observe at the center of the roller, so this is say delta, that is the deflection which can be there at the center of the roll. So to avoid this situation, to avoid the situation of deflection of the roller, what we are doing, we are giving the central diameter little bit more than the diameter at the ends for the roller. Okay, so like this, your pair of the roller will be look like this, not simply by the eye you can see like this, but yes, there is little bit larger diameter at the center than the diameter at the end. Okay, so that is the cambering. And when you are providing the camber, dear students, you are assuring that the load is not, the roll is not going to deflect, it is not having the variation. If the roller is not going to deflect, definitely whatever the thickness you are producing along the lengthwise direction into the rolling process, it will be always uniform, otherwise it cannot be the uniform. Okay, so please remember, that is known as, to understand this, hum deflection nahi chahte. If you want the undeflected roller, that is you will get the throughout the process the uniform thickness, that can be possible with the provision of camber or cambering on the roll, isn't it? So I hope A is correct. Come on dear students, join this session and do participate into this interaction. It is the interactive session, dear students. So please mark your answer in the chat box. So we are here to discuss that. So what is the correct answer? Cambering or camber, provision of camber. If you are considering roller as the simply supported beam with the uniformly distributed loading, UDL, then the deflection at the center, and deflection if is there, the thickness is non-uniform is going to produce. For that reason, cambering is done. And dear student, one more thing that we are going to do on the roller is what? We are having small grooves on the roller. We can have the small grooves on the roller to increase the coefficient of friction little bit, so that the self entry of the plates can be have into the rollers. That is known as the process of provision of the small grooves, known as ragging. So I hope it is clear. So A, Ahmedabad is correct. A is correct. A is correct. Yes, A is correct. A is. I hope you get the explanation. I hope you get the idea about this. What is cammering, why it is done, and what is the resultant, what is the output of that. Definitely, I hope it is clear. Next question. Shall I go for the next? Shall I go for the next? Chahat, Dhirendra, Chahat. A is correct. Rahul Kumar, Mohan, you are putting the wrong answer. Prakash, please understand this concept. Fine. Take the next question. So dies for the wire drawing are made up of. So dear students, the dies which are using in the wire drawing operation, they are of three types. Please remember, wire drawing operation, when we look at, there are the three types of dies that we are using generally for production of the large size wire. Large size means what? In the case of the diameter. When you are having the medium size, ragging, I told you, the provision of small grooves onto rollers to have the self entry of the plates. Okay, definitely to little bit increase the coefficient of friction. That is ragging. Medium size, and dear students, a very fine size wire, fine size, below say 0.1 millimeter, very fine size, right? So in that case, which kind of dies generally used for this typical classification? Large size के लिए कौन सी die है, medium के लिए कौन सी है, fines के लिए कौन सी? So dear student, please remember that large size wire may be made up of the alloy steels. Okay, it is made up of the alloy steels or medium carbon steels. Okay, but medium size wire, if we want to produce in the wire drawing operation, we are generally go with the tungsten carbide dies. Sorry, we are going for the tungsten carbide dies. Tungsten carbide, or simply can say carbide dies. And whenever, dear students, your wire is very fine, very small diameter, you can go with the diamond dies. So dear students, out of this cast steel is not used, cast iron is not used, wrought iron is not used. So definitely which is the correct answer? Chahat is absolutely correct. Yes, dear students, answer the question. So C, carbide dies, tungsten carbide or carbide dies generally used as a die material in the wire drawing process. Okay, or the dies are made up of these materials. Please remember this. I hope it is clear. Take the next question. Blanking and piercing operation can be performed simultaneously. Blanking, that is the disc is useful, that is a blanking. When the produced a blank or a disc is useful, you know very well this concept. And punching or piercing is what? When the produced hole is useful to you. Okay, so simple die, dear student, generally at a stroke only one operation that we are carrying out. Yes, progressive matlab first you are go for a certain operation, okay, punching on blanking, and then successively not successively, after that you can go for the next station, that is a progressive die. Combination die, you can have the cutting operation or it is combined with the forming operation. Okay, first of all, suppose say you have the blanking operation and the produced blank, you now have the deep drawing operation, like that, the forming operation, the combination of the operations. So very correct answer, that is the punching and blanking can be performed simultaneously, dear student. It is a compound. B Bombay. Combination means what? There is a different, one cutting operation, one forming operation. Cutting में क्या होगा? This punching or blanking. Forming में it's either just deformation of the material to produce a cup. Like first operation it's a blanking, that is you produce the necessary required blank, and now the punch will go again into the die to make the cup of that. Okay, so that will be the form. Whenever cutting and forming is combined, it is known as the combination die. Okay, so B Bombay is the correct answer. Yes or no? B Bombay. Ramu, C नहीं है बेटा. Jay Kumar, it is not D. I hope combination die you get it. Isn't it? Chahat, very correct. Shall we go for the next question? A moving mandrel. Now see, very important, mandrel. When you require the mandrel, when you are going for reducing or increasing the thickness of the tube. So tube making or tube production or tube drawing. So mandrel, where it is used? Definitely we are using the mandrel in case of tube drawing operation. Yes, come on. Yes, dear students. Excellent. Shivani, very good. Shahat, very good. Shubham, very good. Neha, very good. Neha, which question you are answering? Prakash, very good. Yes, Nehal, correct. Arjun, very correct. Shubham, very correct. All are correct. All are very correct. Yes or no? Yes, mandrel is used in the tube drawing operation. Tube drawing operation. Yes, Venkatesh, very correct. So C is the correct answer. Take the next. The process used for relieving the internal stresses previously set up in the metal for increasing the machinability of the steel. So dear students, whenever we are working on the material, whenever you are working on the material, whenever you are straining the material, that is, say we are having some deformation in the material, so sort of the energy bundles which are available in the material, because whatever the work done you are having onto the material, out of that near about 10% of the energy gets stored into the material in the form of the energy pockets or the energy bundles that are known as what? The internal residual stresses. And dear students, when you talk about the full annealing, that is heating the material 50 to 70 degrees centigrade more than the upper critical temperature for both hypo and hyporeductoid steel, it is generally playing with the grain size. So grain size can be increased, so the hardness and hardness decreases, ductility increases for the full annealing. So only the thing is that process annealing, where the grain size is not going to change, only the residual stresses are getting relieved, and you are making the material again ready for the machining with the improvement in the machinability. So that is process annealing. Very correct, dear students. See, oh my god, everyone is correct. See, very good. All are correct. Shivani, it is not normalizing here. It is the process annealing. I hope it is correct. Tomorrow's topic will be metal cutting. Tomorrow's topic, very important. Metal cutting will be there. Okay, so C is correct, Cyan is correct. Very good. Tell me the answer. Coining is the operation of. Coining. That is it is also known as the minting. Okay, or coin production. Okay, this is also used for producing the medals. Coining process, where the pure compressive stresses are produced. Pure compression. Yes, tell me the answer. It is a forging process. Yes, it is a cold forging process, dear students. It is a cold forging process. Coining is generally carried out at the normal temperature. Okay, cold forging, below its recrystallization temperature of the material, we are doing that process. Subramanian, very correct. Shivani, very correct. Nehal, very correct. Vivek, piercing, dear, piercing is a cutting operation. Vivek, piercing is the cutting operation, which is sheet metal working. Netaji, yes, Netaji is there. Welcome Netaji, welcome Subramaniam. right? Yes, yes, yes. AE, JE, some gate. So such a kind of question only you are expect. Even for the Vizag, you can get the BHEL, you take the ISRO. Okay. Good evening, Nethaji. So the level of the question is same only. Okay. Yes, thread rolling. Tell me next question. Thread rolling. Tell me thread rolling. Yes, yes. Come on, answer this question. Thread rolling क्या है भाई? So we can make the thread by using on the lathe. You can make the thread by using the rolling process. Okay. So one is stationary die, one is reciprocating die. The stud is inside, isn't it? So this is one die. One is stationary, and there is a stud. Okay, and the another die is reciprocating over it. Produces what? Or the stud like this, of course. So it will produce as the thread, right? So it is cold rolling. Yes, it is the cold rolling. Yes, yes. Some of the questions you can find here at this level only. Kharse, you see any questions that any PSUs, okay, or even the ISRO also, some of the questions will find the level of this only. Go and see, you will find such a questions. Kartik, coining is of course the cold forging process. Cold forging. And it is conducted in the closed die. It is conducted in the closed die. Of course, it is a closed die forging process. Next question. The fatigue strength of the metal is employed by setting up. See, as far as the theoretical questions are concerned, Kharse, because we are not going in that much details for the calculation. Definitely there are the numericals are there. But we are just talking about the theoretical level. Okay, Kharse. Yes, to increase the fatigue strength of the metal, dear student, what we are going to have? We are going to have the short pinning. Okay, that with the short pinning we are trying to generate or trying to produce on the surface the compressive stresses. Yes, that is correct. That is correct. Yes, class timing again, please, dear students, 7 p.m. 7 p.m. See, this is the second session. We will be having 2 more sessions. Tomorrow's session will be the metal cutting, and day after tomorrow or on Monday we will be having the session on see, combined session I try to have on the welding, metrology, material science, or some part of the industrial engineering. The short pinning is correct. Short pinning is correct. Very nice. Take the next question. 7 p.m. Mushtaq. Yes. Tell me the answer, Kiran. Pratik Sonone and Khadse. Very good. Yes, swagging is an operation. Swagging is an operation of, that is, in general we are trying to have the rough shape of the product. Okay, before we are going for the final finishing, that is known as the swagging operation is related to what? This is one of the miscellaneous or the special forging process. Yes, the forging. Okay, this is the forging process. This is the B. Bombay is the correct answer. B. Bombay is the correct answer. Anurag Avasti, correct dear. It is correct. Kiran, it is correct. Nehal, it is correct. Sunita, it is correct. Excellent, excellent. Yes, very nice, very nice. Take the next question. Yes, now tell me generally the strongest form in which the metal can be used as strongest form. So dear students, if you look at the metal forming process, so very important advantages of this process is that in this process we can able to change the material properties, or we can able to refine the grain size. That can be possible in case of the metal forming, and where you can able to improve the properties of the material. Yes, so that is only related to what in actually in forging we can do a lot. So please remember, in forging operation, yes, we can have the strongest form of the metal. Excellent. So D Delhi, D Delhi, D Delhi is the correct answer. D Delhi is the correct answer, not Pratik. So now Sahib, check kara. So it is forging operation, dear. Okay, we can get the strongest form of the material in that. D Delhi is the correct answer. Yes, now tell me. So dear students, when we talk about the wire drawing operation, dear students, when you talk about the wire drawing operation, we are actually looking for the elongation into the material, definitely. And to get that required elongation into the material, I am always looking for the good ductility of the material. Good ductility of the material. Please remember. And to get the good ductility, you should have the material in that kind, in that fashion. So say it is FC structure, definitely having a very good structure with the ductility, that is they can be very easily drawn into the wire. Say see here, cast iron, zinc, tin, out of these the with ductility which is having more than remaining three, it is of course copper. It is of course copper because copper is more ductile than any other. Yes, we can easily draw it into the wire. Very excellent, very nice dear students, very nice Pratik. Netaji, yes, Netaji, Delhi Capitals, once again Netaji on the fire. Mushtaq, very correct dear. Jay Kumar, very correct. Neha, very correct. Akhilesh Khadse Sahib, very correct. Okay, okay, excellent, excellent. Okay, next. Okay, Pratik. See, large size bolt heads. Large size bolt heads. See, I have given you the hint. I have given you the hint. I have given you the hint. Okay, so this is the process where between the two dies in open condition. See, in open condition, not in the closed dies. These are the open dies. See, this is the movable. Okay, movable platen. This is the movable platen and this is the stationary platen. Platen means die. Platen means die. Okay, so large size bolt heads, dear students, the bolt heads, the hexagonal bolt heads actually. Okay, so these are getting made by first. No doubt there are again we are having the miscellaneous forging processes. So yes, so this is nothing but what? This is the upsetting. This is the upsetting process. This is the upsetting. Very good. Very good. Excellent, Jay Kumar. Why it is so long, D? Okay. Very nice. All are correct. All are correct. See, all are correct. Very good. Very good. I hope this is also done. This question is done. This question is done. Ha, this is very important as far as the very basic concept for the punching and blanking. Take this question and tell me the answer. Yes, yes, tell me the answer. Punching operation. in punching operation. If this is my punch, which is applying the maximum force onto the given sheet material, and this is the die. So dear students, please remember, in the punch the clearance is provided on the die. So clearance is provided on the die. So die is always larger than the punch. So clearance on the die, and here you know that the punch, in the punching operation, the shear is always provided on the punch, the shear on the punch. So I hope the shear on the punch and clearance on the die, shear on the punch and the clearance on the die. In blanking operation, shear on the die and clearance on the punch, shear on the die and clearance on the punch in case of blanking operation. Yes, Pratik, very correct. You are writing also the formula. Excellent, dear, excellent. D plus 2C, very good. If C is what? Radial one. C is what? Radial one. Then it is 2C. Very good, very good. So A, Ahmedabad. A, Ahmedabad is the correct answer. Very nice. I hope all are correct. Why you are saying D, B? It is not correct. It is the A. Please remember. So clearance is given on the opposite. That is, if you are going to provide the making the punching, then provide the clearance on the die. If you are having the blanking operation, provide the clearance on punch. Take the next question. Take the next question. Take the next question. So various operations I will show you here. This is my sheet. Okay, in the sheet I want to produce n number of holes, many number of holes. So this operation is known as perforating. This operation is known as perforating. Perforating. Okay, if I want to cut the sheet like say this, okay, from the surface, okay, so this is known as the notching. This is the notching. Okay, if I want to produce an incomplete hole at the midway of the sheet and I just want to bend that cut part, okay, so that is nothing but the lancing. So whenever I cut the sheet along the lengthwise direction like this into number of slots like this, this is known as the slitting. This is known as the slitting. Whenever I want to produce the hole by a very small punch size, very small punches altogether, I am making the very big hole. This is known as nibbling. This is known as nibbling. So for this given question, dear students, yes, D again, Delhi capital. Netaji, where are you? Yes, once again, D is the correct answer. D, Delhi. Excellent, excellent. Yes, yes, come on. I hope it is okay. Yes, next question, take the flange wrinkles. So wrinkles, which is nothing but the folding produced on the flange portion of the cup, drawn cup. Okay, cup kahan pe banta hai then? So this is like on the flange portion. If this is a cup, so on the flange portion, if I try to show you the wrinkle, that is the folding which are get produced. These are known as the wrinkles or the defect, which is the defect. Wrinkling is the defect. And the same foldings you can have on the vertical wall of the cup. It is known as the ears. It is known as the ears. Come on, dear students. Okay. You should not drop in the numbers. You should be there and please let me know the answer. Yes, any other is there? Deep drawing, deep drawing. Yes. So cup kahan pe banta hai? Where you are going to produce the cup? By using again punch and die combination. This is your blank, this is your blank, and this is your punch. And what is the speciality here? The clearance is nothing but equal to what? Thickness. That is, and you are not going to cut the material, you are going to deform the material into the die to produce the required size of the cup, that is height and diameter. So diameter, sorry, deep drawing is the correct answer. Deep drawing is the correct answer. Yes, Subramanya, it is correct. Rahul, it is correct. Dhirendra, it is correct. Sayan, Jay, very nice. Shivani, very good. Arjun, very good. Shubham, very good. Sunita, very good. Take the next question. Take the next question. In piercing and blanking operation, the clearance provided between the punch and die depends upon. Please, in piercing and blanking operation, the clearance provided between the punch and die depends upon. So dear students, if you know the mechanism of the punching and blanking operation, okay, so definitely you will come to know that is the optimum clearance is required to get the meeting of what, the crack from the punch corner and the crack from the die corner, so that they meet somewhere in the middle. For that reason we need the optimum clearance, which is equal to 0.0032 times t under root of tau, which is the radial clearance. This is the optimum clearance, and which is depend upon what? Yes, from the looking to the formula, yes, it is dependent upon the thickness. T is what? Thickness of the sheet. I hope it is clear. Yes. So B, Bombay is the correct answer. Yes, Pratik, excellent dear. It is root over shear stress. Oh, please. What is the formula? Check it once again. So B is the correct answer. Yes, Shivani, very correct, Shivani. That is radial one. If you want angular, it will be 0.0064. 0.0064. Multiply by 2. So Pratik. Yes, it is also depend on the shear strength of the material, because see, what is F max? See, that is F max. See, basically shear strength, the force, the shear area AS into the shear strength of the material. So the cutting force is dependent on the shear strength of the material. Please remember, Karthik, the shear strength is actually responsible for the force, maximum force, which is nothing but shear area in case of the circular a hole. It is perimeter into thickness into the shear strength, like this. So again, thickness is also coming here. So perimeter is pi d t times tau. That will be the force in the sheet metal operation. Next. See, same question only. Mechanical property that decide the cutting force in the blanking operation. Tell me the answer. Mechanical property that decides the cutting force in the blanking operation. Just now I explained, I responding to the Karthik. Yes, tell me now what is the answer? B for Bombay. Yes, Sunita, Vijay, Neha, Subramanyam, Vivek, Chahat, very nice. Come on, answer the question. Yes, shear strength. So no any discussion, no more discussion. I hope it is clear to you. Yes, Jay Kumar, very good dear. Yes, Dhirendra Kumar, very good. Take the next question. This is also done. This is also done. Take the next. Take the next. Tell me what is the question. It is related to the fatigue resistance of the metal. How we are going to improve that? By setting up the compressive stresses by the short pinning or the, this is nothing but the cold pinning. Cold pinning. Again, B Bombay. B Bombay. Shivan is correct. Shubham is correct. Purva Sudarshan is correct. Shubham Chapagra, it is correct. Sunita, it is correct. Rahul, it is correct. Very good. Very good. Very good. Mani, very good. Arjun, Neha, Arora, Vijay Kumar, very good. Very good. Excellent. 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 The backup rollers. The backup rolls. Okay. Tell me what is this backup roll? Yes, yes. Pratik Sonavne, very correct. Backup rolls are larger than the driving rolls. So whenever you are trying to reduce the force in the rolling operation, reduce the force, that is also known as roll separating force, you want to reduce. Okay, in that case we know it is simply, you can write sigma into the projected area. For the deformation it is LP into width of the plate. Okay, so definitely the force, roll separating force, which is proportional to LP, is what? Root over R delta H. So we can decrease the roller radius. When you are decreasing the roller radius, no doubt the forces are coming down, but at the same time, if to maintain the rigidity of the setup, you have to provide the backup rollers which are larger in diameter than the driving rollers. They are just giving the rigidity, they are increasing the rigidity of the setup. They are not separating. Backup rolls are not going to separate the load. Okay, the load going to reduce by these minimum size rollers, not backup rollers. Oh, please see, everybody is saying see. Why it is see? Backup rolls are larger than the driving rolls because backup roll. Okay, so the backup roll is not actually, because of these small rollers, we can have the decreasing the roll separating force. So in the force formula there is only thing related to the roller diameter, not the backup roller. Okay, so it is not necessary that this backup roller you use it every time and it can reduce the roll separating force. So more correct answer, I should go with the A. Because to increase the rigidity of that setup for the rolling operation, they are helpful. They are actually not. Because of this reduction is actually driving rollers. Okay, you are getting this roll separating force down, not by the backup rolls. Please remember this. A should be the correct answer, dear students. Yes. In 4 high, again like this, same 4 high. 4 high, 2 high, 2 rollers are there. Yes, 4 high only. Yes, the setup shown is a 4 high reversible rollers. Okay, 4 high rolling mill or 4 high reversible rolling mill. So of course, just now we have discussed, no more discussion, the backup rollers are actually larger than the driving rollers. The backup rollers are larger than, yes, B is the correct answer. B is the correct answer. Backup rollers, just now we have seen, this is the 4 high reversible mill actually. Okay, yes, this is B, Bombay is the correct answer. B larger than the driving rollers. Driving rollers. Yes, Shivani, Sunita, Vivek, Arjun, very correct. B, Bombay. Yes, this is a very nice question again. Roll separating force, that is simply the load, you can say roll separating force, or simply you can say the force, or you can simply say the load in the rolling operation. which is given by what? Sigma y into B into LP. Okay, so yes, how can it can be get reduced? It can be reduced by reducing the roller diameter. Yes, just now we have seen. It can be reduced by reducing the sigma y, isn't it? Yes, it can be reduced by reducing the sigma y. Whenever you heat the material above recrystallization temperature, the yield strength of the material is going down, and you can be easily work the material with the little amount of stress below sigma y. Definitely load can be decreased. Yes, by reduction of the coefficient of friction. If you want to write like this formula, according to the P and Rao, if you consider the plane strain condition, 2 by root 3 into sigma y B LP into bracket 1 plus mu LP by 4H average. That is very correct formula. You can get the coefficient of friction here. If you reduce that also, you can reduce the roll separating force. Isn't it? So A is the correct answer. A is the correct answer. I hope, again, if you are providing the front and back tensions, also, you can create the Poisson's effect, and you can have the minimization in the load. That is also can be done by a provision of the front and back tension. Also, you can decrease the load. Yes, match this pair. Wrinkling, as you know very well, it is the defect in the drawing operation. Center burst, very importantly, dear student, the center burst is generally occurred in the wire drawing and extrusion. Wire drawing, the central crack, it may be like the fishtail, okay, or it may be like the arrowhead, like this, the cracks, voids we can at the center. It is nothing but the center burst, which is generally occurring. Please remember, it is generally occurring in the wire drawing first, and wire drawing and extrusion, like the similar things we can have, so you can take it as the extrusion also. Barreling, you know very well, that is the bulging of material. When the insufficient lubrication is there in the forging operation, the diameter is going to be like this. As you know that the sticking friction model is there and sliding friction model is there. For the analysis of forging, initially the sticking condition is going to exist. Okay, so the diameter is somewhat get bulged at the center. It is the forging defect. Cold shed is again, dear students, see, barreling, definitely you can have the upset forging, and the cold shed, which are nothing but the overlapping of the material at the corners in the die. So cold sheds are basically, you can say, the weak joint formations onto the forged material. So this is related to the closed die forging, the cold shed. The certain lap like thing you can get on the component to be get forged, okay, or the weak joints, we can call it as the cold shed. I hope it is clear. All the pairs are get matched. Okay, and yes, cold sheds are occurring. Why it is occurring? Some folding, some cracking at the corners. Why this cold shed is forming? So for this, I hope A is the correct answer. A, everybody is saying A. Wrinkling, deep drawing, yes. Cold shed, it should be closed die forging. It should be 4. It should be D. I hope it is. So check करो भाई, सब चीजें बता दी मैंने आपको. Cold shed is a forging defect caused by which of the following reason? So dear student, this is going to happen because of improper designing of the die. Okay, improper designing of the die. It is the cold shed because of this. Okay, it is not done. It is D is not the correct statement. Improper designing of the die. See, not D, it is a B. Bombay is correct. Hope it is okay. Yes, tell me this question. Tell me the answer for this question. This is your closed container, this is your ram, and this is the extruded product. This is the ram, you are providing the force, and this is your billet material. Okay, and not billet material, this is your billet material, only this. And this is surrounded with what? The hydrostatic fluid. So whatever the force which is provided by the ram is not directly in contact with the billet material, but it is passing through the hydrostatic fluid and it is acting on the billet material. It is known as hydrostatic extrusion. Whenever we are talking for the extrusion for the semi-brittle, brittle or high strength superalloy materials, when you extrude those materials, their brittleness is increasing with the temperature. Okay, and definitely the crack or some defect formation will be there. To avoid this thing, to make them as a ductile material throughout the process of the extrusion, and to have a very good extrusion, defect free extrusion, the process is used as hydrostatic extrusion. Excellent, very nice. A is the correct answer. A is the very correct answer. Which of the following material is used in the manufacture extrusion nozzles? You know very well, it is the white cast iron. Extrusion nozzle, which material is used? The white cast iron. Match the following. Yield point phenomena generally occur in the low carbon steel or the medium carbon steels. Yes, of course, container wall friction will be of course zero, because no billet material up to container, it is in between and surrounded by hydrostatic. So dear students, yield point phenomena, definitely there is a inhomogeneous transition from the higher yielding point to the lower yielding point. Okay, in the yield point, definitely we can explain this phenomena with the help of the dislocation theory, because the quadral atmosphere and all, initially you will require the very high huge amount of stresses. Okay, and then after that the quadral atmosphere at somewhere else and your dislocation at somewhere else, so the stresses are coming down. That is the yield point phenomena generally occur in the what? Low carbon steel. Spring back effect, it of course it is spring back. There is what? The elastic recovery of the material. Wrinkling is what? So this is actually defect because of the planar anisotropy. So in a single plane there will be the compressive stress, in a single plane there will be the tensile stress. Okay, isn't it? And residual stresses, these are nothing but whatever the working you are doing on the material, so out of that some of the energy gets stored inside the material during the deformation. Yes, so that energy bundles definitely are nothing but the residual stresses. So yield point phenomena, yes, at the elongation point, dear students. So that phenomena actually you will get the lines from in the yield point region, the bands you can observe under the material. Okay, so these are generally inclined to the 45 degree when the elongation is going to occur there. So these bands are known as the Hartmann lines. These lines are also known as the Hartmann lines, or it is also known as the Luder's bands. These are known as the Luder's bands. Okay, so P yield point phenomena, it is related to 2. Okay, spring back is due to what? Distortion of the dimension. It is the distortion of the dimension. Okay, wrinkling is what? Oh, sorry. So residual stresses is of course compressive. It is because of the plastic deformation. It is because of the plastic deformation. S will be matched with the 3 and P with the 2, Q with the 1. Yes, distortion of the dimension, that is nothing but the spring back, and leftover wrinkling with the compressive. Yes, that is correct. So D is the correct. D is the correct. What hearing for first time? Abhishek Khadse. Luder band. These are nothing but at the yield point phenomena. You will get when there is a yielding of the material. Some marks, stretch marks are occurred onto the specimen, your test specimen, and simply they are only visible when there is a huge deformation will be there. Okay, these bands like this, Luder bands or the Hartmann lines. क्या बोलते हैं इसको? Hartmann lines. Okay. The spring back, it is generally occur in the bending operation. This is nothing but the elastic recovery. Residual stresses के बारे में मैंने पहले भी बता दिया आपको. Okay, fine. So dear students, tomorrow once again मिलेंगे हम at sharp 7 PM. We will be discussing the questions on the metal cutting. Okay, very important topic. So you can see here the Gradeup Super has launched, dear students. Gear up, rank up. This is the batches for 2021 examination. You can see the details here. Okay, and dear students, if you are willing to have the Vision Gate 2022 or ESC 2022, you are planning for, definitely this Vision 2022 course is very ideal course, very excellent course for those people who are right now in the second and third year. They can join this course. Definitely you can see the course details here. No one in the market is going to give you the things like this, right? So now very good. So do follow me on the Gradeup app, dear students. Do follow me on the Gradeup app. There are again various free series that are going on. So right now my series on the additive manufacturing is running every day at 12 PM in the noon. Come and join. You are welcome there. Any query you can contact on this given number. These are our star faculties from the Gradeup. These are our achievers in top 100. Okay. So tomorrow once again we are meeting. At 7 with the topic metal cutting. Do join the session and do share the session amongst your friends. Okay, and like the session. Thank you so much, dear students. Thank you so much for joining the today's session. So I hope कल फिर मिलेंगे. Till then, good night and do take care of your health. Okay, thank you so much. Good night. Bye bye.